Check 1, 2. Yep, we can hear you. How's everybody doing out there? We're going to finish strong here, finish day 2 strong. So good afternoon, welcome to this panel. And I think you'll find that it has a really exceptional group of AI practitioners and thought leaders. I'm very happy with the group of panelists we have. I'm Bill Lescher, the 41st Vice Chief of the Navy, and I'd like to thank the Navy League, Sea Air Space, and the BCG team for putting together really this great opportunity for us to share insights and challenges with each other. The problem statement that we are going to discuss for the next 60 minutes is how all the stakeholders in this room can best work together to bring alive the potential of AI, specifically the potential to make a substantial impact on the service's ability to field ready and lethal forces at scale. So we're going to talk about the force development, force generation challenge that I think everybody here is tracking. I think as most of you know, the foundational way with which we fight, which is the Joint Warfighting Concept 3.0 and the service-related operating concepts of distributed maritime operations, littoral operations in a contested environment. All of these operating concepts require distributed forces at scale as an imperative for both survivability and lethality. Survivability to require defeat in detail broadly, lethality because it provides multi-axis, multi-domain threats to the adversary. Basically, these warfighting concepts are designed to provide the virtue of mass without the vulnerability of concentration. And the scale imperative is all about and is driven by the geographic scope of an Indo-PACOM fight and the very real likelihood of a protracted fight with force attrition. Unhappily, the constraints to delivering the required scale and forces, again, in development and generation of forces, the constraints are plainly evident. They include in new construction the multi-year billion-dollar-plus backlogs that each of the defense primes has today in delivering today's force, which is less than the scaled force required. In repair, significant backlogs and weak performance in the repair industrial base, similarly not delivering the required performance to sustain today's force, let alone a force of significantly greater scale. In procurement, the continued growth in unit procurement costs for our legacy systems that raises a real question about the affordability of fielding our exquisite systems at the scale required. In sustainment, the unaffordable level of sustainment funding that these systems often require, such as F-35 operating costs that have been on the order of $40,000 per hour. And in personnel, the issue of personnel-intense operating models for legacy systems in an era where the Navy has had gaps at sea of up to 20,000 billets. So the challenge is, if we can't build, repair, afford to buy, afford to sustain, or properly man our most capable systems at the scale required with our current performance, all at a time where the urgency to bring strong, improved outcomes to these constraints is clear, what is most actionable with respect to moving the needle on these challenges with AI, urgently and at scale? So today's panel conversation is going to touch on the elements of where AI can most make an impact and where it can't or may even be a distraction. The critical team behaviors for accelerating AI outcomes. Key elements that enable the ability to move from AI prototype to impact at scale, proven best practices for warfighter-centric implementation, and the most significant barriers that government industries see in their collaboration. So I said we have a really impressive group to explore this problem statement. On my left, Ms. Margie Palmieri is the acting director and the principal deputy chief for the Digital and Artificial Intelligence Officer. Margie's prior roles included director of the C&O Action Group, special assistant to the Navy's vice chief, founding director of the Navy Digital Warfare Office. Margie has deep experience in digital transformation and in leading AI and advanced analytics projects that have improved warfighting and readiness outcomes. Margie's leadership at the intersection of AI strategy and operational execution give her a really unique understanding of DoD's priorities, institutional barriers, and critical lessons learned in scaling AI for real-world impact. Dr. Israel Brumer is a founding partner of Red Cell Partners Venture Studio. He co-founded Zephyr healthcare-focused AI, and he co-founded and is CEO of DEFCON AI, Contested Logistics Capability. Israel previously served 15 years in DoD, including as acting director of CAPE, leading the annual defense program review process for the entire DoD totaling over $3.5 trillion. Israel's extensive experience in defense strategy and resource management and his leadership in AI-focused ventures enables him again to offer a very unique perspectives on integrating AI into defense acquisition and sustainment. Ms. Colleen Graham is the Chief of AI and Digital Innovation at Newport News Shipbuilding. Colleen has over 2 decades of experience in the energy and industrial sectors, where she led AI and digital initiatives that delivered substantial value. At Newport News, she's already led the implementation of a machine learning system projected to significantly reduce injuries, and an industrial Internet of Things platform that achieved a 52% improvement in equipment reliability at Newport News in its initial deployment. So Colleen's hands-on experience deploying AI within one of DoD's largest and most complex industrial partners gives her deep insight into the operational challenges, lessons learned, and DoD priorities on innovation, readiness, and sustainment. I'm with you. And Dr. Adi Zolotov. Adi is a BCG Managing Director and Partner, and she's the Global Data Science Lead at BCGX, which develops AI and digital solutions in aerospace, defense, and the public sector. Adi transitioned from a background in astrophysics and data science. I've known her for quite some time, and I know her PhD dissertation was a simulation of the universe. She's led AI initiatives within DoD. She was Vice President at Center for Naval Analysis, leading the CNA Data Science Division, and she served on a broad array of commercial and federal clients at BCGX. So Adi brings deep experience as well in applying AI to improve defense outcomes, directly supporting this conversation today of AI-driven transformation in capability development and readiness generation. So we're going to start the questions with the ones I highlighted briefly before, but we'll also be looking to include audience questions, because I think that potentially will be the richest elements of the conversation. I think you'll see on your seats a pamphlet like this. If you scan this code, your questions will zap right up front here, and we'll get after them quickly. Finally, I'd like to say, as we start the questions, to stay aligned with the panel's focus on outcomes, we actually have an outcome success metric for the next 60 minutes for all of us here, which is that, and our success metric is that each of you walk away with actionable insights on what's working, what's not, and what's next in bringing AI to the fight. So with that, our first question. So to Yisrael, given your 15 years working in DoD, service as acting director at CAPE, and post-DoD experience as a founder of 2 successful AI startups, what is your perspective on how well the key stakeholders truly understand where AI can deliver a consequential outcome and where it can't, or it's being applied in marginal or misguided ways? Which is to say, where are we truly moving the needle with AI in defense, and where is it a distraction?
Yeah, I appreciate the chance to start the discussion off. And by the way, it is such a pleasure to be here with you. I am such a Bill Lescher fan.
Me too.
You know, at the strategic level, you would think the answer to that question would normally be something along the lines of, we're doing really well in predictive maintenance, we're not doing well in healthcare or whatever. That's not been my experience. My experience has been that there are a couple of key differentiators where DoD does really well, and does really poorly. And the first primary one is the ability to overcome the bureaucratic inertia. And I say that not as a dig or a complaint. I was part of the bureaucracy. I understand the value of the processes and so forth. But I'll give you 2 examples to kind of give you to frame the ends of the spectrum. My first company, Zephyr AI, built artificial intelligence, most advanced artificial intelligence in oncology unambiguously. The company took off like a rocket, and it raised hundreds of millions of dollars backed by the 2 biggest healthcare companies on the planet. It can do unbelievable things. And when I built this, I thought to myself, you know, I like warfighters. I'm going to offer this to the Department of Defense for free. So I went in at the 4-star level, and I said, we have these algorithms. You can look at people who have cancer, and they're, warfighters and their families, and you can literally save their lives. This isn't like a debate. It's, I can show you real clinical data, real clinical results. And the result, and I'll give it to you for free, because the company's doing amazing, and you're good. All you got to do is give us, information about patients, and we will tell you what medicate. Well, that's where things just ground to a halt, right? We negotiated in 3 months, sharing effectively the biggest healthcare data set on the planet with the biggest healthcare company on the planet, 18 months into negotiating data sharing with the Department of Defense, my board told me to cut it out, right? Just stop. And we're just trying to share for free, right? All the way on the other side, though, we stood up DEF CON because we got a call from a four-star saying, hey, we have a critical warfighting problem, and we offered a credible solution, and he just barreled over the bureaucracy in an effort to kind of create an opportunity, did it ethically, legally, appropriately, but said, listen, this is a critical warfighting need, and we're going to do it right. And we were able to deploy a technology really effectively, very, very quickly, that we're really proud of. And I've seen everywhere else on the spectrum across the department. The second piece is the ability to bring operational insight together with revolutionary innovation, technical expertise. My experience is AI is an extremely complex topic. A lot of people think they understand it, but actually understanding what it can and cannot do, where the biases are, when it will confidently tell you an answer that is just wrong, is very complicated. And defense operations is very similar. And you have a lot of situations where revolutionary innovators produce technology that is awesome, but not operationally relevant, or you produce things that are operationally relevant, but not accurate, advanced uses of AI. When you can get those two things together, magic happens. And so my experience with DoD is when you get that mix of operational insight and revolutionary innovation coupled with the cultural inertia sidelined, that's where you see real needle-moving outcomes.
Yeah.
And when you don't see those two things, you don't.
Really, I think well stated. Any other thoughts on this, Adi?
Yeah, I think that's a really great point, because the technologists know the technology and the mission operators know the mission, and they're not always finding the right common channels. I think a challenge here is also that technology right now is evolving so rapidly. There are things that are happening at the cutting edge of technology that folks on the operational side or then DoD, they just don't even know that they're available. I'll give you an example. We now build a lot of AI using agents. So the agents actually do all the programming and they build AI. And in less than a week, we were able to build a tool that showed farmers exactly where to plant in order to maximize their yield in a week. And the folks we were working with they didn't understand, what are these agents, who's building these models, how does it work? And so I think not only is that divide super real, but I think it's actually going to accelerate significantly unless we find ways to build that bridge and have it be constantly, a real positive feedback loop.
Yeah, I think that's really well stated, and it's something that I think we've seen certainly in the Navy's journey many times where, hey, be in love with the mission and the problem statement, not the tech, but as you two talked about, combining it with tech that really delivers a delta outcome and that we trust, because we either trust the data or we trust what we're seeing, and I think that is very well said. Colleen, when it comes to bringing AI competency and impact alive in an organization, I've heard you say before, hey, it's not a tech project, it's a team sport. So really kind of building on the same that Israel kind of alluded to, some of the barriers, the friction, culture, adoption challenges. What have you seen, or what are your thoughts on how to deal with that at Newport News and in the commercial industry space you were before?
Yeah, so I would say one thing in my 20 years of experience in tech, it's not easy. So I think we wouldn't be here and people wouldn't be interested in hearing what we have to say if it was easy. But I did have the privilege of listening to Admiral Cottle talk this morning, and he made some points that I thought were very relevant to our discussion today. He was talking about how in World War II, the Japanese Admiral Yamamoto was famous for saying, "I fear all we have done is to awaken a sleeping giant," after the attack on Pearl Harbor. And he was saying, and I know too because I've read the book Freedom's Forge, which is a great book for anyone who wants to read it, that it was actually years prior to that President Roosevelt sort of energized the defense industrial base with industrial titans like Knudsen to really figure out how are we going to get after World War II should we enter the conflict. So it wasn't Pearl Harbor, but it was that that energization of the industrial base. So I would equate, Knudsen and Henry Ford's factory lines of the late 1930s to AI, digital, and data management today. I think this is one of those big efficiency performance levers that we can pull to help energize the industrial base. And I have a study, a statistic that I like to use that I thought was really compelling. It was by Constellation Research, and they looked over the last 40 years at what made companies succeed and fail in the Fortune 500. And what they found was that over 50% of the companies who failed due to digital disruption. So there's no more Blockbuster, there's now Netflix, there are a decreasing number of taxis, there's now Uber. The companies that figure out how to do digital data management AI, they succeed, and the companies that don't fail. So I think just a good foundation on which to have the conversation. But to get to actually, how do we make this happen? Yes, I do like to say it takes a team. It's a team sport. In my career, I've seen kind of a couple of big kind of easy buttons that are often hit. One is, if I just buy this like off-the-shelf software or off-the-shelf data platform, it's going to solve my problems. That's what the supplier says, so that must be true. And then the second is, especially in AI, if I just throw a data scientist at a problem, they're going to make magic happen. And in both cases, I've tried those multiple times, and they don't work super well. But what does work is to put a multidisciplinary team on the problem. And so when I say that very specifically, technical product managers to lead, UX researchers to understand the user experience, right? Data scientists, data engineers, software engineers, architects, the multidisciplinary team, but then especially make sure that the subject matter experts are involved. So the people whose decision workflows you're affecting are actually involved in coming up with a solution. And the other thing I tell my teams is we're not just delivering digital products, we're delivering throughput in the case of shipbuilding NNS right now. So you need to think about what it takes end to end to actually get to the impact. The other thing is, especially my data science teams, don't chase shiny things, solve real problems. I love generative AI. I use ChatGPT every day, but there are a lot of algorithms, there are a lot of tech that's kind of at the top of the hype cycle, and we just have a tendency to want to chase that. But we have to solve real problems, even when maybe they're not, the most fun or academic or interesting thing around. And I have just a couple of quick examples I wanted to use to illustrate the points. The first was from my time at Chevron. I was in oil and gas for 15 years, most of the time as a data science lead before I joined NNS about 5 years ago. And my teams were going after a product to predict when sand was entering a wellbore. So I know we're defense here, but we're going to get into heavy industrial oil and gas space. There are 20,000 feet below the surface of the earth, there were temperature and pressure gauges. And so my team went after trying to use that temperature and pressure data to predict sand, because if the sand went up the well, hit the manifold at the seafloor, it would cause massive erosion problems. And my team was actually used machine learning, created a signal processing model, was successful in doing that, but that was not the biggest challenge of that effort, as challenging as the data science was. It was actually integrating that into the decision-making of the operators, out on the offshore platform, and then also integrating machine learning and algorithm into this 20-year-old tech stack that just wasn't made to hold AI. So one example. And then the second example for don't chase shiny, solve real problems. I'm a data scientist. I lead data science teams, well, multifaceted teams, but when I came to NNS, I realized if we weren't capturing the data, we weren't going to be doing any interesting analysis. So one of the first things that we went after was an industrial Internet of Things initiative. So that was just, we have 60,000 pieces of equipment. Very few pieces are actually connected and flowing data. So if we want to get after equipment reliability and predictive analytics and condition-based maintenance, we're going to have to start flowing that data. Long story short, we got out there, we launched a pilot on our panel lines. At the time, our panel lines were our biggest bottleneck shop from a throughput perspective, and connected up all the equipment, did basic analysis on it, but just through that effort of connecting the equipment and looking at it, we were able to see 52% improvement in equipment reliability. Now, the other thing I wanted to say, it's important to measure your ROI and then on the back end make sure that you're actually seeing the ROI that you expected to get. While we were there, though, we also realized, and this is probably familiar to some of you out there, our shop floor is running on paper and phone calls. Like, it is paper and phone calls. And so likewise, we decided to go after crane operations and automate the whole process of doing a lift, which was huge for that shop because they do over 8,000 lifts per month. So just automating that process, gathering the data, understanding how crane operations were performing, we saw 25% improvement in efficiency. So again, just to summarize, and sorry, I took probably way too long.
No, that was
Admiral Lescher, I'm sorry, but it's a team sport. Multidisciplinary teams very important. And second, don't just chase shiny things, but solve real problems.
No, that's great, and I share the enthusiasm of our audience and seeing that come alive at Newport News. It's just really so critical. So I heard you say absolutely the challenge and the urgency of making the data available, the team sport element, know your role and how it contributes as part of this broader team to the mission outcome, and then where you started with the power of setting the conditions for success, getting the fundamental blocking and tackling it right, all really powerful. D, so once those conditions are in place, many thoughtful stakeholders have come to believe that DoD's subsequent challenge, once the conditions have been set for success, is not that we have a prototyping problem, we have a scaling problem. So from your perspective, why do we so often see that we can't scale what seems to work? What's preventing us from progressing beyond successful experiments to sustained, scaled impact?
Yeah, I think this is certainly a problem in DoD, and Admiral Weeks mentioned it yesterday in his panel, that he sees a lot of prototypes, and yet they mostly stall out. But it's not just a DoD problem. I think on the commercial side, we see that 75% of CEOs are experimenting and adding AI to their business, and less than 25% have seen value. And that is exactly that problem, because value only comes from scale. So I think this is a super complex process, but first and foremost, I think sometimes we're prototyping the wrong things in DoD. We get excited by the shiny technology, or we make, I know you all will be shocked to hear this, a very compelling and passionate argument that's not data-backed sometimes within DoD, and the analysis of the ROI isn't real and isn't robust. And so I think what happens is the funnel of prototypes puts out and develops things that are not necessarily going to be high value, and that generates some fatigue from our people, right? Another prototype, another thing, it's not obvious what's going to be real. Maybe just one example, I saw this tool get built out to help increase wrench turning time, ensure maintainers have exactly what they need so they can spend more time wrench turning. Wasn't particularly well thought out, and in the end, what happened was it actually increased wrench turning time, just given the complexity of the tool and how it was built out. So too many prototypes that are not exactly right. The second, and Colleen, I think this goes with the points you were making on the composition of the team, is you need to engage your users from the first day. You don't engage once you've built out a prototype, and then you're trying to go to scale, only to find out there's a whole host of people who don't want to scale this capability. You've got to engage your super users from the first day. So what's up with our users? Some of them are worried about losing their job to technology, and that's a very real fear, so they're going to be resistant. Some of them don't want to learn another technology, right? Just another thing that they have to do. And they're afraid that this is an additional task, right? We're just adding, we're not actually subtracting and making their job easier. And so you build a prototype, there isn't a groundswell of users saying, we absolutely need this, we need to scale this. And maybe they're even going to be active detractors, even though this might be something that at scale would help them. And so not engaging the user base is a huge issue. The third piece is, and I learned this from you, Admiral Lescher, when we worked together, these things have to subtract. You can't just constantly add to a process. So I think we often think of building a technology, but we don't redesign a process. So you just take a process and then you glom on some technology, and it doesn't make sense. It's not clear where to use it. Perhaps you've got one system that recommends one thing, and now someone has built you this new shiny technology. It recommends something different. I mean, how often have you seen that, right? ERP uses a simple 4-quarter moving average. It predicts this. I have this brand new, shiny, amazing technology. It predicts this. But I have two, and one is a system of record, and one is this new prototype tool. The fourth is we don't test and validate prototypes like we should. Prototypes are built, duct taped together. Some data scientist or some engineer comes to you and offers some amazing sounding accuracy or amazing value, and it's not robustly tested and validated. And that is even more true now in the world of Gen AI, which is really hard to test and validate and capture accuracy metrics around. And so, of course, our people don't trust it. And how can you scale out and make a big investment on something that you don't trust? And then, the foundations is the technology piece. We're not always thinking about the technology we need to scale when we're building a prototype. So we build a prototype, and then we find out, oh, we don't have any GPUs, so we can't scale that out. So I think all of those really work together to create this huge funnel of prototypes and very few that can actually get scaled out and have the support.
Yeah, no, that's really well summarized. For sure, we live the dream of seeing all this enthusiasm for new tech that's always additive. The metric is not that it's used, the metric is, hey, what is it replacing? What is it powerfully delivering as well, for sure. I absolutely resonate with the test and validate comment. Managing, understanding, leading persuasively with an explanation of the what's in it for me, so it's not a fear of the tech, but how it makes it easier to do our job well, or it leads us to gap closure, all resonated. And you started with engaging users from day one, which brings me to Margie, because I know you've had a front row seat in witnessing gaps and time lags between what warfighters need and what industry is working to build. So how do you think about ensuring that the voice of the warfighter stays at the center when it comes to AI implementation? And any examples you might highlight of either where that alignment powerfully delivered or failed to deliver?
Yeah, first of all, it's super encouraging to hear some of the themes that we have lived inside the department echoed in different places across the commercial sector and in our industry partners. And I think this really dovetails into, how do we design capabilities that are right for the user? And then that's really what we want. We want the mission outcome, and we want the user to really get excited and be willing to adopt the technologies, because it's, in this space, we focus a lot on the tech, but it really is the adoption piece that we want to use as our key metric here, because that's what leads us to the outcomes. And so, it's a little counterintuitive for the department to write fewer requirements than more requirements, but that really is one of the first steps we have to take in this space. Because the tech is evolving so quickly, because it is so customized to the workflow, and how the human and the machine team together is really what gives us the best outcome with the tech and the people together. We have to actually step back from over-specifying exactly what we're looking for, and we need to allow, we buy things in the department, we don't necessarily build them, so industry and our users to sit side by side in the context of the mission. And this conversation between the data experts and the AI experts and the mission experts is absolutely key, and we can't put a paper-driven or linear requirements process in between that. We have to, set the right boundaries and conditions for what we expect to, pay for and buy as a department, but then really create the conditions through experimentation to allow users and industry to interact together and build this in an iterative way. AI is not like the hardware capabilities we build that are going to be around for multiple decades. They really are responsive to the environment, they're responsive to the tech. They're even different than software, and I feel like the department's just kind of getting its feet underneath it with software procurement, that, we're doing a little bit better there, but AI takes it to the next level, because it's not that you deliver a software release and then you start planning for the next one. It's you deliver the AI capability and you start monitoring the environment and you start getting that feedback, and your user starts interacting with that algorithm, and then the environment changes or the user has new requirements, and you're constantly in this iterative process. So the way we've approached it inside of CDAO is really to create experimentation venues and opportunities. And a lot of times when we think about experimentation in the department, the lab environment comes up, and our research networks, and a bunch of civilians and contractors running around with badges, and maybe there's an operator there, but they've kind of left their tents or their ships or their natural habitat aside, and they've found a nondescript building off the interstate somewhere to do this testing. But to the other panelist's point, being able to interact with those users from the start in environments where there's live data, live networks, live problems, you're not hand-waving away the hard parts of what it really takes to do the implementation. And I think a lot of times the integration challenge or the scaling challenge is also related to the fact that we tend to build, prototypes or capabilities off to the side. And then they work really great when we give it, the right data set and the right conditions to succeed. But when we bring it into the operational environment, well, now it has to work with our legacy systems. And now it has to sit in a workflow where users are trained to do certain things in a certain way. And now the AI is doing that for them. So what's their role? And how do they interact with the person sitting next to them if now there's a computer in the loop? And so I think we have to we definitely do not just have to focus on the tech. We have to also think about the policies, the processes, and all the enablers that come with really changing the way we work. And that has to be done in an environment that reflects the real world and that presents those real world problems. And then when we run into them, we can't say, oh, that's a policy problem. We have to go after the policy problem and make sure that we're removing that barrier, because we can guess probably pretty well, through data-driven decision-making, of course, what capabilities we think our warfighters need in the next, couple years. But then the conflict's going to happen, and we're going to get real-world responses from the environment, and then we're going to have to figure out what we need in real time. And if we don't have those pipelines set up so that we can be responsive to those requirements, and we have the ability to really understand how they're going to perform, so when we give them to the users, they have the confidence on how to rely on them. If we don't have that pipeline set up, that's where we'll run into challenges with greater agility in the future. And digital transformation is equally about using the tech as it is about getting more agility out of an organization.
Yeah. A lot there. Really well stated. You really highlight what came to my mind, the mindset, culture, of, risk aversion piece that underpins so much of what you said. I have a question here from the audience that actually kind of dovetails into this a bit, Margie, and I think if you'd like to take the initial stab at it. The question is, besides leading change, as you're in this process of implementing, how do you think about managing risks? And so they're talking about, for example, unintentionally disclosed secret or proprietary information, or more generally, what do you see as the downfalls and vulnerabilities with using AI, and how we think about that?
Yeah, we have, whatever name it goes by, whether it's responsible AI or safety or security, at the end of the day, a user has to have justified confidence in using a capability. So for every weapon we field in the Department of Defense, we know it's P sub K. How do we know it? We've tested it, we've tried it out in different conditions. We have a good sense of being able to tell that operator that weapon is going to hit the target 80% of the time. AI is no different. We want to be able to know with confidence how should we expect it to perform. And if it doesn't perform as expected, what are the steps we take as humans in our interaction with it? So, for example, one of the things we use AI for is computer vision. So you see the same thing, you're identifying, that's a facility over there, this is a facility over here. And now we put weapons on target and the facility is blown up. Well, your AI is not going to perform as well as it did before, because a blown up facility and a whole facility look slightly different. The user has to recognize that when the performance of their algorithm starts to change, there's something going on. And then we need the mechanisms inside both the tech and the human processes to be able to say, something's different here, or I'm not getting what I expected. I need to now update the tech, or I need to update my process and change the way the decision-making works. And in the department, a human is always responsible for the outcomes of the capability that we use as the department. So that's no different whether we choose to fire a weapon or whether we choose to rely on an AI recommendation. And as decision makers, we need to have that confidence, and through a good test and evaluation process, through key principles, it's not that we eliminate all risk, because if what the AI is doing was performed by a human, you'd still have error. And so we're not looking for 100% out of our artificial intelligence capabilities, but we need to know, are we looking for 80% or 30%, and how does it fit into our workflow?
Excellent.
Yeah, I guess just one comment on that, which is I think, you know, I sit with kind of one foot in the defense world and one foot in the kind of Silicon Valley world, and I can put on that mindset at different times and think both ways, which is kind of a fun exercise. I think there's a cultural sort of gap where the Silicon Valley folks have this move fast and break things culture that is very real and generates a lot of revolutionary innovation in a very impressive way. And they don't understand why move fast and break things takes a lot of risk in the military. Because, you know, if you're a startup and you go under, it is very bad. It is bad for you. It is bad for your investors. It is bad, you know. But if you're a military and something very bad happens, it is very bad in a much more egregious way. And the risk balancing discussions are different. On the other hand, I think the Defense Department is actually at real risk of becoming, I usually refer to it as becoming agoraphobic. And what I mean by that is agoraphobes, you know, people who refuse to go outside, are actually accurately assessing tactical risk, right? They're inside all day, and it's a safe place to be. You go outside, you can get run over by a car, you can get mugged. That's not going to happen to you inside. And what they're doing is they're accurately assessing tactical risk and mitigating it, and they're manifesting a guaranteed strategic risk, which is that they spend their entire life inside, and that's highly undesirable. And I worry a lot that the Department of Defense is in a situation where a series of tactical risks, the risk of spillage of classified data, which is real and is a serious issue, the risk of spending taxpayer money on a contract that doesn't yield results, which is real and needs to be taken very seriously, that those stack up, and the end result is we're at significant risk of a catastrophic battlefield failure in the near term, and that worries me a lot. And actually, one of my answers to the question of how do you get people motivated is, I think, that understanding. You know, I think there is a very unfair kind of public understanding of I used the word bureaucracy before, because that is really seen as a very negative term, but I don't see it that way. You know, a quality bureaucracy effectively executes a leader's directives in a way that minimizes certain risks and maximizes certain outcomes. But I do think that when the risks are properly balanced, you get very different outcomes than you're seeing right now.
I think the other lens that is aligned with that is what's going on elsewhere. So what is happening with AI with our adversaries, what's happening in Europe and NATO, and what's happening here. Very different models of accepting risk with AI and innovation here in the US, in DoD, and in European MODs, just given the laws that regulate data and AI in Europe. And how is China using data? And how is China developing its AI models? And so we've got to figure out what's our right risk tolerance, but it cannot be in a bubble, because there are others who are lapsing us, and we're also seeing folks who have been very, very conservative, like in Europe and NATO, where they're very risk averse, and now they're finding themselves very behind. And that's got to be part of the way that we evaluate how fast we push and how much risk we're willing to take.
Yeah, very good. Another question, and this can be to anybody that as the questions come in. This one's about a number of defense prime leaders have observed that a constraint on the pace of AI innovation defense is that it is significantly harder to essentially make money, make profits selling software to DoD than hardware. So I'd be interested in hearing anybody's perspective on that. Do you agree, disagree? And if you agree, what changes come to mind that would make it easier to transition or to succeed in selling software to DoD?
Yeah, I mean, I've spent most of my career in government, so I can't necessarily talk to the industry side of whether or not you can make money from the outside, hardware versus software. I think there's a couple challenges with selling software. One is, we have not done a good job as the government at providing very fast and expansive access to our networks and our data. Because we buy hardware mostly, and we know how to buy hardware and it's familiar, we tend to lock our data up into silos. And one of the things we're trying to do in CDAO is unlock the data, free the data, so that we can really make it available for software providers who don't offer a full stack. Maybe you do offer a full stack, we don't need the full stack, but we want to buy the data platform separate from the apps. And we have an initiative in CDAO called Open Dagger, which does exactly that, where we procure the data platform under separate contracts from the applications, and then through government-owned, DevSecOps pipelines, we own the data, we own the APIs for the data platforms, and then we can protect the IP of the third-party vendors coming in that want access to the data but don't want to share their IP with the platform, providers themselves. And so we're working this year through a couple examples of that. But unlocking the data and providing them to software companies that have innovative solutions is really key. And I think there hasn't been the opportunity to make a ton of money, well, I shouldn't say that. I don't know about the money side, but there hasn't been a lot of opportunity for us to engage those third-party software providers because our data has been so locked up in individual providers. And when I look at the mission space and how much opportunity there is to bring in, the ability to now connect users and software companies together to solve problems, once they have access to our networks and our data, those can happen at local levels where all the innovation takes place. It's closest to mission need. It's where the problems are going to be solved in the most effective way. So if we can unlock that ecosystem in between there, I think we will see just the demand signal take off. The other piece is on the contracting side, and how hard is it for smaller companies, especially or non-traditional companies, to have access to DoD business. And in that case, we have a platform called Tradewinds in CDAO where we're trying to reduce the barrier of entry by, you can do a 5-minute video, you can go through competition, you can be on the Tradewinds marketplace, and then anybody in DoD can award a contract to you. And so if we can link these pieces up, the access to contracts, the access to our networks, access to our data, and then access to our users through those experimentation environments, I think we've got some key unlocks that really create that pipeline and that ecosystem that can allow the department to start developing at scale with one of the biggest assets we have in this country, which is our industrial base and American talent in the digital space.
Yeah, perfect.
So you said at the beginning of this, I was thinking about my answer, and I'm moved by your comment at the beginning that there need to be actionable insights. And so I was kind of thinking through the various philosophical comments I want to make that are not actionable, and decided to focus on one that is, which is that, look, there just aren't that many people who built a startup outside defense and inside defense. And so I can kind of directly compare the experiences. And there are some aspects that are very similar, and there are some aspects that are very different. The most egregious delta is the fact that in the outside defense world, every engagement, you get feedback, lots of feedback, so much feedback. I mean, and not all of it's good. You get people who love you and people who hate you and people who hate you for good reason and bad reason. You walk away and you say, this customer's never going to buy AI, full stop. This one loves what you're doing but realizes that you're going to disrupt their business model. You're going to put them out of business, so they want you dead. This one's going to buy what this one would buy it if you could only prove this or make this improvement or do this thing. And sometimes that thing's impossible and sometimes it's not. You go into the Department of Defense and you just walk out and it's like trying to read tea leaves, right? And we're not like 19-year-olds in a garage. Like, I used to run K, my Navy advisor used to run the Navy. My Air Force advisor used to run the Air Force. My acquisition advisor used to run all of acquisition, right? And we have no idea half the time what to make of the feedback. And it means we spend a lot of time doing things that's time wasted. We'll build things that we think are awesome, that if we had just tweaked it this, we could have saved a lot of time. And I think that is a consistent problem across the entire defense industry, and I do think that's very actionable. I'm very familiar with, again, the tactical risks associated with open communication, because I used to sit on a lot of those sides. And I'm just a believer that today, at no cost, with effort from both industry and the Department of Defense, we could make a 90-degree turn on that communication, and you would see an explosion of innovation, an explosion at no cost. So that is one thing. If folks want to take away something we could do today, let's do that.
One of the things I've heard you say, Israel, related to that really made an impression on me is when you're in the evaluator mode at Red Cell as an incubator, regardless what your decision is, invest, not invest, you're always relentlessly encouraging to the entrepreneur, because you recognize how incredibly difficult and the risk associated with that. And I was looking here, I don't think you touched on it there, but that element of not only let's ramp up the communication, let's be radically transparent about the problem and the potential, but also, even when deciding no, to recognize that you have individuals really out there, all in, to solve DoD's problems.
Yeah, I'll comment on that somewhat at my own risk. When you're looking at startups, novel technology, look, I'll say this from my old, Cape days. We did plenty of studies that showed that it is literally impossible to know which tech is going to work and which tech is not before the tech either works or it doesn't. And anyone who pretends otherwise is fooling themselves. You can make good guesses, you can make informed guesses. The more revolutionary the technology, the more you have to try it and just see if science will let you move in that direction. Particularly in the startup world, which is the primary purveyor of revolutionary innovation in this country, for very good systemic reason. That's not an accident. There's a whole body of academic work on that. That's true. It's really hard to tell the difference between Steve Jobs at 19 and some guy who thinks he's Steve Jobs at 19. And anyone who thinks that there are people who are very good at it, and they tend to make their name in venture capital, and they're really effective and can replicate that success. But for the most part, there is some aspect of luck and some aspect of you just don't know. I have always believed, when an entrepreneur comes to me and brings me, particularly on the Red Cell side where I take a lot of venture pitches, and says, I'm going to dedicate my life to advancing the technology of the United States government, to protect the warfighter, to minimize warfighting risk, I'll fund you, I won't fund you, I'll work with you, I won't work with you, but I'm giving you a big hug because you're doing the right thing, you're spending your life in the right way, and I want you to feel that encouragement. And I will tell you, when I watch the feedback that these entrepreneurs receive, because again, and I don't think it's intentionally, I don't think there's anything nefarious, it's just the tone of, I bring you my baby, and I say, look at this baby, and isn't this baby beautiful? And you say, I have chosen not to select your baby for procurement, right? And I think we have probably lost, I will tell you, I've watched some of the most advanced technology on the planet go do things that would make you cry rather than deploy it to the warfighter because of that simple lack of a moment of kindness. And I do think, again, if you're talking about actionable, free, I used to be Cape, so nobody's gonna beat me up more than I've been beaten up, okay? But if you're, really it is, if you're a young entrepreneur, you've put your life into this, like, hey, what a beautiful baby you have. I'm not gonna buy your baby today, but I wanna thank you for bringing it to me.
Yeah, for sure.
That's free, that's easy.
Yeah, low hurdle there. We'll still take questions coming in, but let me pitch one to the group here, really across the board. So we talked about this panel having a focus on moving from promise to real performance, real impact, delta outcome, as we like to talk about it, with AI-enabled force generation. So what are the most significant barriers that each of you see as you work to really in this ecosystem as part of this team to deliver those outcomes? Any specific changes or approaches you need from the commercial or government partners that would really, in some respects, building on what Yisrael just said, but really help us deliver velocity to iterative learning, iterative progress, and fielding impact at scale?
I'll start this one. I guess I kind of have the opposite experience as Yoke, because 15 years in private and oil and gas, right, and then now almost 5 years in defense. It was a bit of a culture shock for me, and that's coming from a 150-year-old heavy industrial Chevron to another 150-year-old heavy industrial, but still a culture shock in defense. And I've spent a lot of time thinking about why is it, why is the risk aversion, why is it slower, why is the performance slower, why is everything harder? And I recently read kind of a manifesto, I won't call them out, but some of you may have read it, by a tech CTO, and he put forward that, like, capitalism, if we bring capitalism and competition to defense industrial base, that's going to solve our problems. And I loved it because I'm American, and, like, capitalism, yes, it's a thing. But I really started thinking about it in our context, right, and the huge shipyards and the huge investment that the American people have made in these shipyards. And not just that, the majority of our expense in the fleet is in the public shipyards, so we're not going to fix that through building more public shipyards. So I think we really need to lean into the things that we do have. And I can say, for me personally, the reason I came and I made the change to defense is I took an interview. And I wasn't going to take the interview, but they were like, you really need to take this interview. So I was, okay. So I sat down with these people, and I proceeded to have an hour-long conversation with people that were more passionate, were mission-minded, had more integrity than anyone I had ever worked with. And I said, that's it, I'm done. I'm going to go do this. This seems amazing. And so I think one of the big things that we can tap into is the mission and is the impact that people can have. Now, I will say the caveat to that is we pay. If you look at the Fortune 500 for tech talent, whether it's technical product managers, solution architects, data scientists, we pay half of what they pay. So I think that we can get a lot of people who have a passion to make an impact, but we have to make compensation at a level that this is a viable career path for tech talent. I think that that's a huge barrier. The other thing, and I talked about it a little bit, we need to fund and allow for lighthouses. And I think this gets a lot to what Israel's saying, but and we talked about prototypes and piloting, but, really, so don't say, I'm going to go all in, right? I'm going to fix the defense industrial base. I'm going to do, like, IoT across. No, that's never going to work. It's too big of a problem. But we have to get great minds together with subject matter experts on a problem, like what we did with our panel lines, and make a lighthouse. So show what great looks like. So we have to give those teams the autonomy, the flexibility, and the funding to actually do that. So two thoughts there.
Yeah, very good.
I think we need some courage from our DoD leadership. I think Admiral Lescher, to the times that we worked together, AI was just kind of coming onto the scene. And we could have been completely relegated to the back office and completely ignored. Marjorie, I think you and I sometimes were completely ignored in the beginning, until some of leadership took the meeting, understood what the unlock was, and were willing to take a gamble on leveraging new technology and making decisions off of it. And I think if the bar is so high that leadership isn't willing to make the decisions, get behind it, push it forward, sometimes it takes time, right? The ROI isn't always instantaneous, and you're going to hit bumps along the way. And so I think some courage from leadership to champion and help the vanguard initiatives get to value, I think can be a barrier removal for the initiatives that come after it.
Yeah, perfect. So we're getting toward the end. I think we've got time for one or two more questions, and I'm looking at a couple from the audience. Let me try and put these together. There's a couple of questions related to this idea of requirements, and I think, Margie, you were talking about powerfully about the idea, hey, we're in an era now where, particularly with this type of tech, there's a co-evolution of ConOps and technology. And so I have a question here on JSIDs, a question on how do we convey requirements in a way industry can meet demand. Israel, this was proposed to you. And then a broader question about the relevance of JSIDs, PPE, DoD 5000, the FAR regulations in this context. And so it's an immensely rich conversation about which we have a very kind of fractured approach to bring speed to innovation with the Navy Disruptive Capabilities Office and the RCO and AFWorks and Army's Futures Command and DIU, but all powerfully pointing to this idea of a different way of thinking about requirements, about coevolution of tech and requirements, and again, this idea of a warfighter voice. So if anybody would care to comment on how do we convey requirements in a way that's powerful for commercial industry, and how we basically bring speed to innovation adoption.
Yeah, I think a couple things. The value of this technology is it is agile, it is flexible, it is responsive. It doesn't require systems of systems engineering for years before we understand how to write some code or test some code with a user. We can do this in an iterative way. If it's not what we expected initially, we can rewrite the code, we can try again. So I think we have to take advantage of the fact that this technology is incredibly flexible. And that we don't need a one-size-fits-all process for all of the things that we buy and build in the department. That for the ships that are going to be around for years and sustained, for decades, they need a rigorous requirements process. For our weapon systems that are required to, execute a kill chain where lives are at risk, we need a systems of systems engineering process that's going to ensure that we've got the right data flowing to the right decision makers and through to the execution. But in the cases where we are doing other functions, whether it's on the business side or the warfighting side, that are not as rigorous or as lasting, and predictable, we can be much more flexible. In those cases, I think there have to be core requirements set at an enterprise level around interoperability and accessibility of data in particular, of the underlying compute infrastructure and some of the tools that we use so that we can be interoperable as a department. One of the challenges we've had in building our systems and buying our systems to date is that once we buy them for a specific function, we realize that we actually want integrated functions, and then we have to spend a whole bunch more money on top of that integrating the things that we just bought that meet our requirements but didn't quite meet the integration requirements in the context of the mission. Or the mission evolves and now we have new things and we want to be able to integrate them. So we have to be much more thoughtful from a requirements perspective at where are those interoperability points, and how do we want to leverage the technology across different components of the department and not have to refactor it every single time. So I think there is absolutely a role for some, I will use the word standards, but it's not like a mill standard. It's more, core principles, core architectural, principles that we know around loosely coupled hardware and software and interoperable open APIs, things like that. After that, the requirements really need to be mission outcome based. And there's so much innovation that can take place in the development of the technology and the interaction with the user. A lot of times our users may ask for something because they think that's what they need, but actually when they work through the problem, they find out they need something a little different. And we can give them space to work through that problem and solution set. And we can do it in a competitive way with industry. We can have challenges. We can bring in multiple companies to do bake-offs that really, one, expose the industry base to more of our problem set, which is huge. A lot of the things that we work on, some have analogous, analogies in the commercial sector. Some of them don't. And so we have to create mechanisms by which we can bring industry in. And then once the users and industry understand each other, then we have, okay, what's the mission outcome? Okay, well, I know you asked for this, but actually we could deliver that. Oh, I didn't know I could ask for that. And you need that space to be able to do that. I think that's where experimentation can come in and help us in those real world scenarios that we can have the context for the tech and provide the feedback to industry on exactly, they can see why it didn't work or why it wasn't the best solution, and they can get the feedback directly from the user. So I think that traditional process by which we try to not guess, but write the requirements ahead of time when we don't know how the technology is going to perform, we need to write it in the context of the mission outcome and then step back and let the process kind of work itself out.
Absolutely. Mission-driven is the way. Any other thoughts or comments on this?
Requirements processes are really designed for evolutionary innovation, not revolutionary innovation. There was no requirement for DVD by mail when we were all going to Blockbuster, or for streaming when we were all doing DVD by mail. There was no requirement for a horseless carriage, there was a requirement for a cup holder in the horseless carriage, by the way, which took a really long time for people to get around to, interestingly. There really are very few mechanisms for a revolutionary technology to be presented to the Department of Defense. There's no requirement for a time machine or a teleportation device or because revolutionary innovation appears to be impossible and out of the realm of the imagination before it's provided. That is something that I think, again, actionable. And I think people also, there is a baby with the bathwater problem, where actually requirements process does really well. If you're going to build a carrier, you need really firm requirements. You need to understand what you're building. If you don't have firm requirements, you're going to end up with something that you don't like, But for revolutionary innovation, there needs to be a way for the revolutionary innovators of the country to come to the department and be heard, and for there to be rapid action on the timelines that startups can survive through, because the speed from decision to action for the Department of Defense exceeds the average runway of the average startup by probably a factor of 2 or 3.
Yeah, without a doubt. That's been a core priority, I know, in the Navy, which is we're seeking to match velocity of decision and action to velocity of learning, right? So we're doing prototyping, we're doing learning, and then we get into the friction of, in execution you're reprogramming, et cetera, that really gets to that heart of that problem as well. Barring any other thoughts, we appear to be at time. And so as a quick summary, I've looked at some of the notes. I really appreciate the thoughtfulness of the conversation. I think we've heard some strong examples, principles, some of the key behaviors regarding what it takes to move AI from pilots to operational outcomes, gaps of policy, workforce, incentives, mission voice, enablers of mindset, culture, velocity of learning, et cetera. So a helpful conversation, much work to be done, much opportunity to succeed. So thank you again to Sierra Space, BCG, and I'd like to have a round of applause, please, for our panel.